Hello everyone, my name is Joyce Manatad and I am from BSA2J. So now I will be discussing one of the experimental design that I chose which is the Latin square design. So what is Latin square design? Latin square design, it is one of the experimental design that has the capacity that can simultaneously handle two known sources of variation among experimental units, and it considers the sources as the independent blocking criteria compared to RCBD, which the blockings are only referred to replication. But here in Latin square design, we will be discussing bidirectional blocking, which this experimental design commonly referred it as row blocking, which achieve to ensure that every treatment occurs only once in each row blocks and once in each column blocks. In Latin square design, there are also restrictions, which is the impractical use of experiments with large number of treatments, and it has the limitation regarding the treatments that we should consider with, which is the number of treatments must be not less than 4 but not more than 8 treatments. And how does Latin square design is assessed in this in every experiments? It makes it possible to assess variation among row blocks and even among column blocks, and to aim to reduce experimental error. Design are appropriate for experiments, and it has also the condition to meet the general assumption regarding the ANOVA table. First, we should consider that every number of treatments must have an equal category of sources of variation, like just like the replication and the treatment, that and even the column is equal in result and equal to its total or the summation of it, and the absence of interaction among the two sources of variation and the treatments. This is our Latin square design layout for our sample treatments. And as you observe, no, na there are 5 different treatments in one column and 5 different treatments in rows. So there are different treatments, which is treatment 1, treatment 3, treatment 4, treatment 5, and treatment 2. And the same also here, treatment 1, treatment 2, treatment 5, treatment 4, and treatment 3. Though they are randomized, but then it is the general variations among the in the two sources of blocking. As we lay out our data here, so as since this is our treatment 1, which is belong to the row 1 and the first column, so we will put it here, the 3.30. Same also for the 4.33 and so on. So now this is our table for our to know what is the row total and to know where is the column total and its summation, and even the treatments assigned for each respective organic fertilizers as sample. This 130.54 is the summation of all the values here in the row total, which is result to 130.54, and even in the summation of the column total, which is to sum it up, these 5 column totals, which will be 130.54, and the treatments is also varies on its treatment 1 as we designate our treatments here. Now this is our table for our analysis of variance table or the ANOVA for the Latin square design. And as you notice, Since RCBD is commonly it involves only treatment and rows, but now the column is considered Latin square design. So same process to RCBD to compute the F tab and even first the F computed value. So that would be my presentation and discussion about the Latin square design as one of the experimental units in statistical experiments.